All right, this is part two of the discussion of proof by contradiction and proof by induction. I know you probably are not seeing anything right now, so let me pick out the right window first. And I think that should do this. Okay. So I think you should be seeing the right window at this point. For some reason, when I stop OBS, it chooses it, it chose not to maintain the window that's being captured. All right. So anyway, at this point, we're gonna finish the last question, which is a proof by contradiction type of example. So in this case, it is quite clearly stated what the theorem is. The theorem states, for all x, y, p that are natural numbers, p equals to xy implies x squared is less than or equal to p, or y squared is less than or equal to p. So it's quite clearly defined what the theorem is in this case. So what we need to do is to take this theorem and negate it, and then find out what's going to happen when we negate the theorem. All right, so so the first thing we need to understand is the theorem itself is an implication. This entire thing is an implication, which also means we have to find out how to negate the implication. And then furthermore, the theorem itself states for all, and the negation of that is going to be there exists where the inside is negated. Okay. So the first thing we need to do is to take this whole thing and then we say, okay, how do we negate this whole thing? So we state the negated theorem is the following. I'm just going to be a little bit lazy here. We'll do some copy and pasting. And it is just with a negation on the outside and one more close parenthesis here. Okay. But this means, okay, so we're going to take this whole thing and then we'll start to massage it a little bit. Okay, copy and paste here. So what we do next is we apply this given derivation here. When you have a negation of for all, you basically take out those guys and then you change it to a there exist. And in the process, we can get rid of one of the parentheses. But at the same time, we also need to negate the theorem itself. So we basically move the negation to the inside of what we had earlier. Okay. And the negation of implication is let's take a look at that. Okay. So when we have A implies B to begin with, the negation of A implies B is the negation of not A or B. Okay, not A or B. And then we use De Morgan's law, which turns out to be not A and B, not B. So this becomes A and not B. All right, so using this, we can now say, okay, we take this whole thing, we take this entire whole thing, and then we paste it here. So what we need to do is to say the negation of the implication. Okay, we identify what is A and what is B. So A is not negated after we negate the entire thing. So we just keep P equals to XY just the way it is. Okay, let me select the right portion, get rid of that. And then we also get rid of the implication because we change everything to, in this case, a conjunction. And then the entire part B is negated. So now we put a negation here. And the rest is really just a matter of matching the parentheses. So let me see, open, open, close, open, open, close, open, close. And I think we probably got the right parentheses at this point. And then we apply the De Morgan's law here again, so that we end it up here. Just copy and paste again. Okay. And so what we would do here is to apply De Morgan's law here. So we take out this negation, and then we apply the negation to each individual component inside. And then we also change the disjunction to a conjunction. And then we add another negation here. There we go. All right, so we're almost done. This also means, okay, so I'm doing this really step by step. So we take this whole thing, copy and paste. Okay, so this negation basically is just, I can turn the comparison operator around and say, not less than or equal to is just greater than. Okay, so we just do this part and make it greater than. Okay, so let's see how this reads right now. We are basically saying there exist x, y, and p. They're all elements of natural numbers, where p is the product of x, y, and x squared is greater than p, and y squared is greater than p as well. Okay, so now let's just focus on that portion. Okay, that portion is basically saying x equals xy, and x times x is greater than p, and y times y is greater than p as well. Okay, so what does that imply to us? Well, so we can basically now say, let's consider p times p, and x. So we square both sides here. Okay, so this entire thing implies that p times p is x times y, xy times xy because of this equation here. Okay, and naturally this is just x, y, y. Okay, because multiplication is associative, we can change the ordering of the multiplication itself. But because x is greater than p, or x squared is greater than p, and y squared is greater than p as well, so now we say, pp is x, y, y, p squared is x squared times y squared, and we also know that p squared is less than x squared times y squared. And we have a contradiction because this cannot happen. A value cannot be equaling to another value and be less than the other value at the same time. And that's our contradiction. We're done. All right, so this is a really kind of short follow-up of the first video, but I'm gonna stop streaming now and have it uploaded, change the title, on YouTube so that you guys can locate it more easily. All right, so even though we didn't meet today in class, I still managed to cover all the material that I'm supposed to cover today. Alrighty, I'll see you guys on Monday. The test is next Wednesday. Today is the 8th, so the test is going to be on the 15th. If you have any further questions, do not hesitate to ask. I can use this particular method to distribute additional videos over the weekend if it's going to be helping. All right.